Okay, so I'm asking you now that what you learned LU method, right? LU decomposition method, right? Why LU decomposition method we learned? Because it is efficient in solving. LU decomposition was efficient in solving the linear equation, simultaneous linear equation of the form Ax equal to B when different right hand sides. When right hand sides, LU decomposition is an efficient method to solve it. Therefore, LU decomposition method got popular. Even Python has a LU function which you can use. Just give the matrix A as input, and the output of that matrix will give you both L and U. And your assignment was that it did not give only these two quantities. It gave you something more, that is P. That is the permutation matrix. Now, my question is, did you do that assignment? Yes. So please answer. Okay, so why we have permutation matrix in that? We saw in Python. Observe that in your previous example in the previous class, like we had this example where the first element was 10 to the power minus. There we did two experiments. One was this, then one experiment was we swapped. This was one matrix and this was another matrix. We swapped the equations, okay? And we came to know that this was producing very odd results with a tiny change in your decimal points, okay? But this matrix was producing very consistent results. I request you to kindly see your notebooks in the previous class, okay? So you can see that why this has happened. So sometimes this has happened because you had this very tiny number and you are dividing that number, okay? So therefore, these kind of ill-conditioned systems can happen. So those kind of ill-conditioned systems, your computer, Python, already finds it out. So this LU function doesn't just only decompose, rather it checks whether your matrix A is ill-conditioned, whether your matrix A in your first element is a very small quantity. If it is small quantity, it uses the permutation matrix to swap the rows. Just it. I suggest the output you get in Python using the permutation matrix, you multiply again and again with the coefficient matrix A. You will see that every time you multiply, the row gets swapped, just like the Rubik's Cube. In the Rubik's Cube, you just swap the things, right? Rotate it again and again till you reach. It's just the same thing. You swap the rows, swap the rows. Every time you multiply the permutation matrix, you are swapping the rows. You are swapping the rows. Okay. So therefore, permutation matrix is there in your output of LU in Python. Okay. These things you should know at least the basics. Okay. Be knowing. Okay, in such deep things. This is a study where you apply both the computational techniques and mathematical techniques to understand this. In that way, it is very important. Okay. And that's what we are trying to bridge here. It's just not math. It's something computational involved also. Okay. So now I got motivated to tell you this, that LU decomposition can also be used in computing. What? In computing? Yes. LU decomposition method can help you in computing the inverse of a matrix. Of course, a square matrix. Yes. How? How? So here we will break down. We will break down the problem into very tiny pieces. We will break down. That's what computer program does. How we will do that? You know that if a matrix A is of n cross n, then if you compute the inverse of the matrix, what should be the size of that inverse matrix? It's the same, n cross n. Okay. So you know the structure of the inverse of the matrix. You know the structure of the inverse of the matrix. That means it will have n rows and n. Okay. What we will do using LU decomposition is we will compute each column of the inverse. Okay. We will compute each column of the inverse. This is the nth column, 1, 2, so on till nth. So we will find each column. We will find each column of the inverse matrix via the LU decomposition tool. This is the main idea of solve. To use our method. Okay. How LU decomposition is helping you? How LU decomposition is helping here? I told you. LU decomposition. The above I told you in the beginning of the class that LU decomposition works superbly when your right hand side vectors keeps on changing. Yes, you can use LU decomposition method. It's very efficient. It's very efficient. The same technique we are going to use here. Okay. How? All right. So you can solve this equation Ax equals to B1. Suppose we are taking a 3 cross 3 matrix. Suppose A is a 3 cross 3 matrix. That means the inverse will also be a 3 cross 3 matrix. You can compute the 3 columns of the inverse matrix by this way. You have to solve 3 different linear equations. Okay. That will give you the answer for each column of the inverse matrix. And solving this, Ax equal to B1, Ax equal to B2, Ax equal to B3, where you see the right hand side vectors are different, and these right hand side vectors are something new. And what are these right hand side vectors? These right hand side vectors for you will be unit vectors for you. Unit vectors. Unit vectors in the sense this will be 1, 0, 0. This will be 0, 1, 0. This will be 0, 0, 1. Solve this matrix equation, then it is guaranteed that the output of this, that is x, will be the vector, these vectors. Okay, which you can just paste it there, isn't it? Can you understand this? How many of you got it or not got it? Did not get. How many of you did not get? Did not get. Others got it. Did not get. Did not get. Okay. Fine. Okay. Let me repeat again. See, your job is to compute the inverse, isn't it? Your job is to compute the inverse of the matrix A. A is what matrix? It is the matrix present in Ax equal to B. You want to compute that A. Why you need to compute the inverse of that A? Because it is useful in many cases. One such trivial case is, it will be. So it is useful to compute an inverse of a matrix. Okay. So how to do it? How to do it? I am telling you that let us recall our simple fundamental thing that what is the strength of LU decomposition? Strength of LU decomposition is it is useful in the case where your right hand side vector keeps on changing and A matrix is still the same. I told in the beginning of the class this concept. Why this is the case, why Gauss elimination is very poor in this case. Understood? Yeah. So therefore what it happens is if you, I told let us take the 3 cross 3 matrix. That means how the inverse will look like. The inverse looks like this, isn't it? Yes. Everyone agreeing me? Yes. Now I'm saying you to calculate the inverse of the matrix. You just find these vectors. This inverse is made up of these vectors. Okay? This inverse is made up of these vectors. And if you solve Ax equal to B1, where B1 1, 0, 0, then the output you get will be this x1. Solve B2, that is 0, 1, x2. X2 is this vector. solve Ax equal to B3, which is 0, 0, 1, then you will get x3, which is this vector. If you can find x1, x2, x3 just using LU decomposition, then did not you get the inverse of the matrix here? This is a theorem. I'm not doing it. I'm telling you that if you solve Ax equal to the right hand side is a unit vector 1, 0, 0, 0, 1, 0, 0, 0, 1, then solution, three different solution will give you three different columns of the inverse matrix. That's it. That's the theory. Now you will know it better when we do an example. Okay. Let us do an example. Let us do an example so that you understand. Okay. Okay. Ready? I think you must have had a hard time before computing inverse of a 3 by 3 matrix. 2 by 3 matrix is okay. Adjoint and something you do, you can get it. But 3 by, I think you must have never calculated by using your hand, is it? Yeah, that is the case. But the thing is, for the 3 by 3, it's very hard, isn't it? Computing by hand. Yeah, yes. 3 by 3, I'm just giving you an example. Other example, but 3 by 3, we will do it in class. Let us do 3 by 3. Take this vector, take this matrix as example. Everyone should work parallelly with me to understand the concept. Don't lag behind. Okay. This is a 3 by 3 matrix. I am asking you what is A inverse by LU decomposition technique. So as usual, suppose I will give you a boost. What is the boost? That you don't need to find what is L and U. I will be giving it to you. Okay. So you can use the Python also. I suggest now you could do it in Python. Do you want to use Python? No? Compute L and U. I did not give the code, is it? I have not shared the code. Okay, I will share it. But anyway, you can appreciate that this is the L and U. I am giving it to you. After this, the real method starts. Okay, I am giving L and U for you. Note it down. So for this matrix A, I decompose this matrix A into L matrix and U matrix, lower triangular matrix and upper triangular matrix. Okay. Now I suggest you how we should proceed in computing A inverse. How to find A inverse is our aim. Okay. So how shall we begin? So our aim is to solve three equations. Yes, that is Ax equal to B1. So first we will solve this. What is A? You can see here. What shall we take? B1 you take to be first 1, 0, 0. Okay. That means LU LU. Carefully remember how you solved LU x in equal to B. How you solved LU x equal to B? You have to look into. Equals to y, suppose. Then you solved Ly equals to B1. Yes. First, this is you should solve first. Then you should solve this one second. The order is different. Okay. Don't solve the second one and then try to solve it the first. First, you should solve Ly equals to B. Okay. What is L here? What is L matrix? You have the L matrix. 1, 0, 0, 0 0.033, some, yeah, continuing 1, 0, 0 0.1, minus 0 0.027131. And this is y1, y2, y3, isn't it, which you want to calculate? B1 is, I told you, the unit vector, that is 1, 0, 0. Can you just tell me what is y1, y2, y3? It will be, because it is a lower triangular matrix. So y1, y2, y3, what you get? Now what should be your update like? You found y, right? You found y, isn't it? Where you should use the y? You should use the y in the second equation. So use y, y1, y2, y3 to solve. Ux equals to y. That is the first, that is the second step for you. Okay. Now what is u? U is the matrix you have. 3 minus 0 0.1 minus 0 0.2, 0, 7.00333 minus 0 0.29333, 0, 0, 10 point, this one. And have x1, x2, x3, which is your required, desired first column. This is your first column, x1, x2, x3. y1, y2, y3 you already know, minus 0 0.033, minus 0 0.1009. Okay. Can you tell me what is x1, x2, x3? So as some of your friends suggested, this one was x1, x2, x3, which is your first column of the inverse matrix. So this you can see, this is 0 0.334249 minus 0 0.00518. This one is minus 0 0.01007. Through this method, you computed the first column. Okay. Now, the other two columns are remaining. Okay. Which I think you can do. Maybe after lunch, we can see the remaining two columns from you. Okay. So what you need to do for the second column, to obtain second column, what you need to do? Yes, Ax equals to B2, where B2 will be 0, 1, 0. Okay. A is still the same, ln to u, which you have already used, and solve it. This is the new vector, that is x2 I am calling. Now the third column also you can solve it. Similarly, how? Ax3, that is this is the third column of the inverse matrix, equals to B3. B3 is the, again, another unit vector. solve for this, you are getting the third column of the matrix. That is x. This is x2. This is x3. This is what just right now. Vector. Okay. So hopefully maybe after lunch we can try this.